Okay, this is our video about wedges, and we're going to kind of look at just the picture of them first. You don't have this to glue in, but I just wanted to show you this. Basically, we think about wedges, and we're thinking about IMA. We have DE over DR. So our effort, like if we're hitting this wedge with a sledgehammer to split this log, our effort is up here. So the distance that this goes in here, the distance I move this wedge in, that's my DE. And then the distance this moves apart is my resistance. This log is held together here, and it's the force inside the log holding it together, so the distance of the resistance is this distance that goes out. If I push this wedge all the way in, it'll eventually move this material this far apart. And that right there will be my DR. So my DE is the length of the wedge, and my DR is the width of the wedge. I can have a wedge like this that's a double wedge, or I can have a wedge that's shaped like this that's a single wedge. Still, this would be my DE, and this would be my DR. That's slightly different from our inclined plane. You do have this picture to glue in, and this is basically showing the same information I was just saying. Our DE over DR, this here is my DE, and they call this the length perpendicular to the height. It's this length here is my DE on this side. And then the height, they call this the height, but it's how wide the wedge is there. This is my DR. So I think these letters are a little tricky, but if you realize that this is my DE, because it's how far I have to push the wedge into the material, and the DR is how wide it is, that's how far I'm pushing the material apart, it makes a little more sense. This information and this formula are on your formula chart under section 13, so you can totally look them up. So let's go ahead and do the IMA of this wedge. IMA equals DE over DR. DE is 10 inches. DR is 3 inches, giving us 10 over 3, or 3.3 repeating for our IMA. Okay, so here is a very realistic engineering problem. And this one is a little tricky because, look, there is one of our special right triangles from geometry. So we first know that this wedge happens to be in this shape. So I'm going to start by, what should we do every time first time? That's right. Right off we should always draw the picture. And here they tell me what it should look like. If it's a wedge, it's got to be like this. Here's my 90 degrees, and that's got to be 45 and 45. So there's my wedge shape that's going to cut, in this case, a steel plate. So down here I'm trying to cut a plate, a steel plate in half with this wedge. And it applies 2,000 pounds of force. So that is my effort. And the shear, the wedge, the shear, has a 1/4 inch thick cutting blade. So this side right here is a 1/4 inch. And if I know this is a 45, 45, 90 triangle, how wide is this side here? That's right, it's isosceles, so this has to be a 1/4 inch also. So if we consider what we just had before, this is my, pull my picture over here. This height is my DE, and this part is this part right here, that's my DR. Now that I've got my picture completely drawn out and labeled with all my parts, now I can go ahead and do this. First of all, it says, what's the length of the slope? This side here, what's the length going to be? How would we find it? Well, you can either use your Pythagorean theorem, or if you happen to remember your 45, 45, 90 triangles, you could totally do it that way. I'm going to go ahead and do it with my Pythagorean theorem. So I have 0.25, because a 1/4 inch is 0.25 squared plus 0.25 squared equals c squared. And when I do that, I get, gotta do my calculator really quick. .125 equals c squared. Then what do I do to solve this? That's right, we need to take the square root of both sides. And we get that length has to be 0.35 inches. And does that make sense? It should make sense because this side is our hypotenuse, so it should be slightly longer than those other two. So that makes sense. And then B says, what's the ideal mechanical advantage of the wedge? IMA equals DE over DR. Well, that's 1/4 over 1/4. What's anything over itself? That would be an MA of 1. Okay, that's it for this example problem.